Hello, in this video I explain the usage of the index register Z or Z in a Mitsubishi Melsoft PLC. Hello and welcome back, this is Gerd Zeller and here is how it goes. Well, in order to explain the purpose of what I'm showing you here with the Z index, I already prepared a program to show you how that whole thing is working. So let's say you have a PLC, FX5U PLC, and you do not have a programmer and you want to be able to display the status of the program in the HMI. Therefore, on this first item right here, you can put, let's say, you can check the X5, input X5. So if I put this to 1, you will see a change on here in a display. Also, I can put any number in here. Let's say we want to check on the number 20, at the input 20. So if I switch on the input 20 right here, you will see the input 20. There is a display switching on here. I can switch it off again, and on here we have, I just made 2 items, so we can double check that with the X11. Same thing, turn it on, it changes the display, turn it off also. The same thing is happening with the M register or M bit or Boolean variables. So let's say I want to test the bit number 4, the status of the bit number 4. I switch it on, you can see a change on the display right here. And I switch on the 21 in this variable table right here. You will also see the 21 switches on. So this is how to read that. And then also, let's say you wanna set a bit. You can do this on here. I just put the number 91 in, and if we switch this on, we can see the bit number 91 switches on and also off. And if I put the 21 in here, you will see it switches on, and also you get a display back or a feedback back on the display. And that way you can easily see the status of the bits. And the same thing is with the outputs, the Y. So on here I can switch on the output 1. There you go. And I can change this to output 15 or whatever you please to do. And then you can see the display, the output Y51 switches on, and on the second one the same thing. Let's say we want to switch on 25. There you go. You can see the 25 is being turned on here. So how is this whole thing made in the software, respectively in the setup in the HMI? So in order to do this, you need the Z register, which you can see down here, the respective numbers. I'm gonna switch off all the simulation mode. And let's see how this is done. So the first thing is, to see the input index, I just made an input field where I say this is the index Z0 right here. And the Z0 is displayed by the M311. And if we switch over to the GXWorks, you can see there is an index X0, which is actually starting with the index Z0, sorry, the index Z0, which is starting with X0 right here. I'm gonna make an edit mode so we can see this X0, Y0, and if any value regarding in the Z0 is 1, we switch on the M311, And the same thing is with the Z1. The Z1 or the Z1 switches on regarding to what input is switched on in the switches on the M311. Sorry, the M312. And the same thing is done with the M bit. So I start here with M0, Z5, and that just gets written over to the M310, which you can see on here. So this is the Z5 switching on the M310. So if we want to make, I can just show you exactly step by step on how to program this. Therefore, probably we will check the input X first. Therefore, we input a row, we put in X0, and then we use the Z6, and we bring this over to the, let's say, M312. And this needs to be a coil right here. There you go. So, in the visualization, we make an input field, object, numerical input, right here. Just put this on this empty spot here. The important thing is the format, because in an FX5U, the inputs and outputs are in octal order, so you need to make the format in octal right here, and we make the Z6, if I'm not mistaken. Yes, and then we make a lamp. Use a bit lamp for the format of the light right now. It doesn't really matter. It's just in order to show you how this whole thing is working. And I did use the M312. So let's put the M312 in here. And off we go. So this will be, just put a small text here so we understand what I'm doing. Index input. All right, so that should be pretty much it. Make it black so we can see it better. And now I think compile it and run the simulator, and then we, okay, here we go. So if we put, let's say we put an index in here from 11. That was too fast. And we switch on the bit, the input 11, our light will change right here. You will see that it changes. The same thing will happen if we put any input in. We can put whatever, 45, and switch on the input 45, and we will see that we have a change right here in the light. If I switch any other input on, I will not be able to see it. See that? No display right here, only on the 45, which is indexed right here. And also you can see the status of the register. Z6. We have we cannot display it in octal in here. So anyway, if we switch that off, and we put a 5 in here, then you will see it changes to 5 on here, and also the light switches on with the display number 5. Okay, so much for the input. The same thing happens with the output. We can keep the Z register on here, and only make the program so that it's get written. So here we got the C6. So let's go ahead, change this here. So we want to change the output display. So let's say we go to Y0 for the output 0, starting with the register 6. And we just put a always 1 in there. And maybe we put a M, let's say 320 in there to switch it on and off. Therefore we make a bit switch where we switch on the address M320, put that in here, device M320, and we can just make this momentarily, so we can switch it on by pushing the button and it switches off by releasing the button. Should be the same result if I made everything correctly. We got the M320, we go to the output Y0, which is indexed with the Z6. So if we, let's say we want to switch on Y11, push the button, and as long as we push the button it's on, and if we release the button it's off. You can modify this button with toggle on off or however you want it, but this is the way you change it. If you want to do this with the M register, you can do this the same way. It's gonna work the same way like with the inputs and outputs, only instead of X and Y you use M. I almost forgot to tell you that when you use the M bit, the Boolean variables, on your input field, you need to put in the unsigned or signed decimal, because this is counting all the way through from 1 through infinitive, whatever number it is, and not octal. So for the M bit, change your format right here. And this is the way how you can use the ingest register Z in a Mitsubishi Melsoft PLC FX5U. Thank you for watching.